Hi everyone, this is the second video in this series of integral calculus from an artist's perspective. And in the first video I kind of introduced you to this concept of using graphics as a means of approximating integrals, and in that first video we approximated the volume of these two spheres, and so the space in between the inner sphere and the outer sphere, and we used a cube at that time. But we're going to extend this even further, and now what we'll also look at is the concept of using multiple shape objects as well as multiple size objects, because you want to be able to say maybe scale your cube up and down, or use a pyramid or perhaps a prism, depending upon the shape of the objects that you're trying to approximate, whether that's an area or a volume approximation. So let's just take a look at the objects real quick individually, and we'll set them in the scene. Let's see. So we have I'll just show them relative to each other, the size. So there's the cube, and there's the pyramid, and there's the tetrahedron, or we'll move them over like that, our rectangular prism like this. So just because, say with this object, we'll just try it with the pyramid for the first part. Let's see, and we'll put the pyramid inside, and there he is inside like that. And we'll just take a look, and right off the bat, it looks to me like, of course, the prism's obviously not the right size object. It's just too big. But it is interesting, they kind of work, and but maybe not in this case. So maybe we'll try something else. We'll forget that. We'll try the let's see, we'll try the cube. Let's see where the cube is in the scene. All right, we'll have to move the cube over and put him in the scene. Alright, so there's the cube in here. We'll add a few like that. It's like, okay, certainly, just simply because it's smaller, it's taking up more space, and so that would certainly be a better approximator. And let's try it for the tetrahedron as well. We'll put that in there, and so that's even smaller. But maybe in fact, just because we'll try it with maybe a combination of a cube and the prism at the same time. So maybe the shape of each helps to improve the approximation that we're looking for. So let me see, I don't know if I changed the values on the size of these shapes yet, but I think you get an idea. So I should be approximating both. Well, I am doing it in here, but let's see. Let's just fill it up. And there's another thing in here in this particular version. What I've entered into it is our error collector. So what we do with this is, you notice from the previous video, the error collection term was when the object popped out of the inside of the sphere. And so what we'll have to do, which I'm not yet doing here, is because I'm trying not to have any errors, I'm going to subtract the error volumes from the actual total volumes when you add them together. I'm just trying to give you an idea how I'll be working with this as we evolve. So let's just fill this up anyway, and let's see. And you can see as it gets close, you can see they get agitated when. Let's see if we can push the envelope a little bit. As it gets closer, they'll kind of, the physics will kind of work against each other, and maybe we'll pop one out anyway. Well, it's interesting, the space, the way it fills the space like that was based upon the location at which I was adding them. So I could actually co-locate them when I'm adding them as well, and that may be a better approach. We're just experimenting. Remember, this is integral calculus from an artist's perspective. This is the way I intend to do calculus in the future. Whether you guys intend to do it or not, that's your choice. But for me, I assure you, I'm not going to spend my life doing equations. Okay, well, I hope that gives you an idea of where we're heading with this. I think next time I'll start adding a lot more polynomial curves, and maybe we'll take approximations over several curves at once, or any other size objects. But really, the value of this is that using approximations when you have a lot of odd shapes within your object, this might actually be a much more intuitive approach. Okay, well, that's it for now, and I'll see you in the next video.